All right, for today, we're going to be looking at, or for this lesson, we're going to be looking at equations of proportional relationships. So it's really easy. Just pay attention again. If you need to take notes, make sure you pause the video and write in your notebook, just like we do in school, and so you can keep up with me, okay? All right. So it says to express a proportional relationship using an equation, you must first calculate, and you're going to calculate the constant of proportionality. And if you are confused about the constant of proportionality, go back and watch the last video, and it talks about the constant of proportionality. But the constant of proportionality is simply the constant ratio that you look for in order to determine if quantities are proportional. So basically, you take two values and you divide them. And if you keep getting the same number over and over and over, we say it's proportional. But that number that you're getting over and over and over is called your constant of proportionality. All right, so we'll take a look at these. The equation of a proportional relationship is always written in a certain form. And this is the form that it's always going to be written in. Always going to be written in this form right here. Let me undo that because that's not what I wanted to do. So that form right here where it has y equals to kx, that's going to be the equation form that proportional relationships will always be in. Okay? So let's talk about this y and this k and this x because they all mean something. All right, so with that being said, let's talk about what these values are. And it says you are not restricted to these variables. Like you don't have to use y, k, and x. I mean, you just got to know what they each mean. All right, but for our purposes, we're going to stick with y, k, and x, so you're not confused. All right, so k is your constant of proportionality. Basically, it's going to be that unit rate, like what you get when you take the two quantities and you divide. So your k is your constant of proportionality. Just remember that, or your unit rate. Y is associated with the quantity in the numerator. So you know when you divide, you have a numerator and a denominator. So y is usually associated with the numerator, so what goes in your numerator. All right, keep in mind we're talking about how to get a unit rate. You have to divide. All right, so y is usually the numerator. Okay, it says you may use any variable, but for right now, we're going to stick with y. Y is associated with what goes in our, x is associated with what goes in our denominator. So when you divide, you will usually take one variable or one quantity and divide it by another quantity. The quantity that's in our numerator, we're going to call it y. We'll label it as y. And the quantity that goes in our denominator, we're going to call it x. All right. So here are some important things to remember because on the last lesson, I told you which one went in the numerator and I told you which one went in your denominator. Okay, so today you're going to have to figure it out, but I'm going to give you some information first. All right, so these are important things. So this is very important. All right, so what we'll do is look at A, B, and C. It says to determine which, A says to determine which quantity represents y, which is your numerator, and which represents x, which is your denominator, which is what goes in your denominator. Think of which, and then it should say which one. Depends on the other one. Okay, so The one that depends on something, which we call it the dependent variable, is called y. If it depends on something else, it's called y. The other one is called x. It's more like your independent variable. Okay, so y is equal to your dependent variable. It's going to depend on something else. And x is like your independent variable. It doesn't depend on anything. Okay, it's the one that can be manipulated. All right, so I have an example. I'm gonna add a few more. So just to start off with, it says cost depends on the number of pounds. Okay, so if I were to go to Walmart and maybe buy, I don't know, a cabbage or something like that, some kind of vegetables. So normally what you do is you take your vegetables or your fruit and you put it on a scale. So why do you put it on a scale? You put it on the scale because the scale weighs it. Why? Because that's how the cost is determined. So the machine, the register, is not going to calculate a cost until the weight is known. So therefore, cost depends on pounds, which is your weight. All right, so since cost is depending on something, it's our y variable. Okay, this other one is our x variable. Your dependent variable, the one that depends on something, is your y variable. So cost is y because it depends on the number of pounds, and pounds is x. In other words, cost, let me go down here. Okay, undo all of that because I don't know what just happened. All right, so cost is your dependent variable. It depends on your number of pounds. Okay, so we say it's going to be y. Well, if it's y, it will go in the numerator if we wanted to divide. And then the number of pounds is our independent variable. So we call it x, and it would go in our denominator. Okay, I'm going to throw some more examples up here. All right, so maybe I could say your weight, and we measure ourselves in pounds. Your weight depends on what? Okay, we could say your weight depends on the number of calories you consume. In other words, how much you eat. Okay. So with that being said, I'm basically saying to you that your weight depends on something. So if your weight is depending on something, it's your dependent variable. So we would say it's more like y. It would go in our numerator. All right, so our weight, which would be in pounds, so pounds is going to be like y, and it goes in our numerator. And what does it depend on? Well, it depends on the number of calories we take in. Okay? So that number of calories is like our x, okay? Calories, and it goes in our denominator, okay? Make that look more like a explanation mark, make quotations. Let me just erase all of that so it looks better. Okay, that's like our Y. And the calories is, since it's not dependent on anything, it's our independent variable, it's our X. So if we wanted to divide something that talked about pounds and calories, we would put the amount that represented the pounds in the numerator and the amount that represented the calories in our denominator. All right, let's take a look at the next one. Okay, so A talked about dependency. Which one is dependent on the other one? The dependent variable is Y, the other one is X. Okay, but B is going to talk about a unit of time. If you ever see a unit of time, it's automatically going to be X. Okay? Automatically. So like you got miles and hours when you're talking about driving or speed or something. Hours is a unit of time, so it's automatically going to be X. Pages per minute. If somebody can read so many pages per minute, okay? So minutes is a unit of time. It's automatically going to be X. So it go in your denominator. Money saved in weeks. Weeks is a unit of time. It's automatically going to be X. So if I wanted to set this up and divide, in this particular case, miles would go in my numerator and hours would go in my denominator because hours is associated with X, therefore miles has to be associated with Y. Let me put that right there so it looks like it makes more sense. Y divided by X. All right, pages and minutes. If minutes is X, that means pages is Y. So you would set this up as pages divided by minutes. Pages is your Y and minutes is a unit of time. It's our X. So it'll be Y divided by X there. All right, money saved in weeks. Weeks is a unit of time, so it would automatically go in our denominator. That means the amount saved would go in our numerator. Okay, so it's associated with Y. That's Y divided by X. Amount saved divided by the number of weeks. Okay? Or besides looking at dependency in part A or looking for a unit of time, part C deals with a rate statement. So a rate statement is going to have like the word per in it or the word to. All right, so you're going to be looking for the word per. I don't know why it's not writing right. Per or the word to. Okay. So if you see the word per or the word to, it should help you to set it up in the form Y to X or Y over X. Whatever the word is before the word per, that's like your Y. Whatever they're talking about before per, it's like your Y. Whatever it's talking about after per, it's like your X. Or same thing for to. So let me show you what I'm talking about. So this says the number of cups, and that's the word to the number of servings. Also, number of cups is like your Y because it's before the word to. Number of servings is like your X because it's after the word to. Okay? So in this rate statement, when you have number of servings number of cups to the number of servings, number of cups is Y and the number of servings is related to X. So you would just take the number of cups All right, something's going on with it. I don't know. I'll try it again. All right, so you would take the number of cups and divide it by the number of servings. Because remember, it's y divided by x. And before the word 2 is your y. After the word 2 is your number of servings, which is your x. This one has the word per in it. And what is before the word per is like your y, which is money. This is money per person. And whatever is after the word per is like your x, okay? So in this case, it would be money, the amount of money, divided by the number of people. So that's y divided by x. Okay, so we see how to set it up. So you can have something's going on with it. You can have a dependency statement. So when one thing depends on another, that dependent variable would be y. Or you can have in B, you can look for a unit of time. The unit of time would always be relative to x. And we'll go in your denominator. Or you can look for a rate statement, which is in C. And whatever's before the word 2 is your y. Whatever's after the word 2 is your x. If you see per, whatever's before the word per is your related to your y. And whatever's after the word per is related to your x. Okay, let's try to move on to the next page. Just hope we can without. Hopefully I'll be able to write on it correctly. Yeah, we're having some problems right now. Okay. Says to determine if the relationship in the table is proportional. Well, to determine if something is proportional or not, you need to divide to find each ratio, divide to find each ratio. And if every ratio is constant or the same, we'll say it's proportional. If every ratio you get after you divide is not the same, it's not proportional. All right. So we're going to determine if it's proportional by dividing. If it is, we're going to write an equation that represents the relationship. Remember, equations are written in the form y equals to kx, excuse me. All right, so let's go forward. Let's hope I can write. All right, so we're going to first determine if it's proportional. Then we're going to write an equation, and then we're also going to find a missing value. I'll show you how to do that. All right, but first, let's just see if it's proportional or not. So look at your units. Well, what 2 units do you have? You have hours and you have miles. Hours is a unit of time. So it's x. And miles has to be y. So when we divide, we want to make sure we divide our y value by our x value. All right, so I'm going to check each one of these. So if I can go 1 mile, 65 miles in 1 hour, I'm going to take 65 and divide it by 1. I get 65. Okay, but remember, to check to see if it's proportional, I got to check all the way through. Or I can go 130 miles in 2 hours. Well, that's also 65. I can go 195 miles in 3 hours. Okay, well, that's also 65. All right, so with that being said, all of them are the same. You're not going to worry about that missing value right now. I'm sure most of you could figure it out, but don't worry about that missing value, okay? All right, so I keep getting 65. So it says determine, on number 1, determine the constant of proportionality. The constant of proportionality is 65, and I'm just going to put 65 miles per hour. But the key thing is, okay, we know it's 65. I attached the miles per hour, so it makes sense. All right, so if I write the equation on step 2, I write the equation in the form y equals to kx. Well, y is equivalent to miles, okay? So we know that. So I'm going to keep the y, though. I'm not going to write the word not going to write the word miles. I'm just going to keep the y. K is our constant of proportionality. And we've already determined the constant of proportionality. The constant of proportionality is represented by a number. So what number represents the constant of proportionality? That would be 65. And then you're just going to keep x. You're not going to write a word for it. So there are no words. You're writing an equation. So y equals to 65. Y equals to 65. X is your equation. Y'all give me a second. Let me turn my phone. Let me turn the sound off on my phone. All right, so y equals to 65. X is the equation. And bear with me. I don't know what's wrong with it. It wants to write sometimes and then it doesn't. Okay, now we're going to find the missing value. So all we're going to do is just throw this number in, 12. Okay. Well, 12 is a x variable. It represents x because it's in the column x that ours is under, and ours is represented by the variable x. So what I'm going to do is substitute an x of 12. So if I substitute an x of 12, and we've done substitution, I end up with y equals to 65 times 12, because all I did was change my x to 12. So your y value, you just multiply 65 times 12, and you should get 780. And 780 what? Well, in 12 hours, you can go 780, and it's in the miles column. 780 miles. Remember, your y variable represents miles anyway. All right, and make sure you attach meaning to it. So just don't put 780 miles. So now what I have done, it says determine if the relationship shown in the table is proportional. I need to put this down here. Yes. Okay, it is proportional. Okay, so I've determined if it's proportional. And then it says determine the constant of, write an equation. Well, to write an equation, you need to find the constant of proportionality. So we found the constant of proportionality. Then we wrote the equation. And then we found the missing value. All we do to find the missing value is you can plug in what you have. If you have an x and missing a y, plug in x to find the y. If you're having a y but missing an x, plug in y and find the x. All right, so you just plug it in and then solve to find the missing value. All right, so let's determine if B is proportional. All right, so to determine if it's pounds and cost is proportional. So that's just like I was telling you about if you go in Walmart or someplace and you got fruits or you got vegetables, your cost depends on the pounds. That's why the way the fruit, the fruits that you have or the vegetables that you have. So cost is dependent. That's dependent. So it's relative to the variable y. Therefore, this has to be x. Pounds is x. So when you divide, you're going to take 225 because it's relative to y and divide it by 3. And let's see what we get. 225 divided by 3 is 75 cents. Okay, let me see if I can make that look better. Okay, 75 cents. Y'all bear with me. I'm doing the best I can. All right, then you're going to take 450 and divide it by 6. Well, if you take 450 and divide it by 6, 450 divided by 6 is also